In this video, we're going to solve one-step equations using multiplication and division. Some things about equations that we're going to keep in mind as we solve these equations is that our goal is to isolate the variable so that our variable is alone on one side of the equation. We're also going to use inverse operations, and in this case we're going to use multiplication and division. Multiplication and division are inverse operations. And the third thing is we're going to balance the equation for each step. My first equation is 3x equal 36. I'm looking on the side of the equation with the variable because I'm going to isolate the variable x so I can find the solution to this equation. The operation that's going on the side of the equation with the variable is multiplication. In algebra, we undo multiplication with division. However, we do not use the elementary division symbols such as this in algebra. Instead, we use fractions. So I'm going to turn both sides of my equation into a fraction, and I'm going to divide by the number 3 because I know that the fraction 3 over 3 will equal 1. Or, in another fraction, 3x over 3, I could cancel out 3 as a factor in both my numerator and denominator, leaving me with the value of x. So I divide both sides of my equation by 3. I can now cancel the 3's out from the side of the equation with the variable, leaving me with just x or 1x. And then 36 divided by 3 is 12. So my solution to this equation is x is equal to 12. Okay, in our next example, 5x equal negative 45, I am going to isolate my variable x again. The operation going on the side of the equation with the variable is multiplication, and I'm going to undo multiplication with division. Division means turning them into fractions. I'm going to divide both sides by 5, and my 5's on the side of the equation with my variable cancel out and become 1, so I'm left with x on that side. And negative 45 divided by a positive 5 is a negative 5. In my next equation, negative 9x equal negative 81. Again, the operation going on the side of the equation with the variable is multiplication. I undo multiplication with division. So I'm going to turn both sides of my equation into a fraction, and I'm going to divide by the coefficient negative 9 on both sides so that I'm isolating my variable x. My negative 9's cancel and leave me with a 1x, and negative 81 divided by negative 9 is a positive 9. In my next equation, I have x divided by 9 equals 6. Notice that I have division in algebra here represented as a fraction, and in order to undo the division so that I'm isolating my variable x, I'm going to need to do multiplication. And we're just going to think about how to get rid of a 9 that is in the denominator. So I'm going to rethink that problem as 1/9, the fraction 1/9. And the goal is going to be for me to get a 1. And what would I multiply 1/9 by so that I could get a 1? Well, I can multiply 1/9 by its multiplicative inverse or its reciprocal, which is 9 over 1. 9 over 1 would equal 9 over 9, and 9 over 9 equals 1. So this is what I'm going to do. I'm going to multiply both sides of my equation by 9 over 1. And we do that by showing multiplication dot on both sides, and we multiply both sides by 9 over 1, which is also 9. And on the left side of the equation, my 9's will cancel out, leave me with the variable x, and then 6 times 9 is 54. And if you don't believe that that's the solution, you can check it. And you can check it by going back to your original equation, which was x divided by 9 is equal to 6. You can plug in 54 where you see x, and 54 divided by 9 is equal to 6. That's a true statement, so it checks. Now, one thing that I always, as a teacher, have to listen to is students saying, well, why do I have to do it like that? Why do I have to show this multiplication here and this one here? Well, that's because you're doing this part. You're balancing your equation and you're showing people that this is how you balanced your equation by multiplying both sides by 9. Again, balancing means whatever you do to the right side of the equation, you must do to the left. Okay, let's look at a few more division problems. In the first example, I have x divided by 12 is equal to negative 3. My goal is to isolate my variable x. The operation that's going on the side of the equation with my variable is division. I undo division with multiplication. So I'm going to multiply both sides by 12. And on the left side of my equation, my 12s will cancel because the fraction 12 over 12 is equal to 1. And I'm left with the variable x. And negative 3 times 12 is negative 36. In the next example, I have a negative x over 4, or x divided by 4. And students are always curious as to where does that negative sign go if it's in the middle by the vinculum. And really, you want to get rid of everything that is on the side of the equation with the variable, including the negative sign. So we're going to assign that negative to the 4. So we're going to think of it as a negative 4. We don't want to have a negative variable as our solution because it's truly not the solution. So let's start by rewriting this so we can see really what's going on. I have x divided by negative 4 is equal to negative 7. Now the operation that's going on the side of the equation with the variable is division. We undo division with multiplication, so I'm going to write a multiplication sign on both sides, and I'm going to multiply both sides by what is in the denominator of my fraction, which is negative 4. My negative 4's will cancel out and leave me with the variable x. And negative 7 times negative 4 is a positive 28. So my solution is x is equal to 28. And if you're not sure, you can check that by writing your original equation, and we'll put x over negative 4 equal negative 7. Replace your x with 28. So I have 28 divided by negative 4, and 28 divided by negative 4 is a negative 7. And that checks. So the solution to this problem is x is equal to 28. Thank you for watching how to solve one-step equations using multiplication and division.